To my amazing students, I say welcome back to further mathematics class. In this class, I'll be taking you through vectors 2. The lesson outline include the triangle law, the parallelogram law, scalar product of two vectors, and lastly, angles between two vectors. Before we proceed, the triangle and the parallelogram law are applied in vector addition. Now, the triangle law of vector addition states that when two vectors are represented as two sides of the triangle with the order of magnitude and direction, then the third side of the triangle represents the magnitude and direction of the resultant vector. I repeat, triangle law of vector addition states that when two vectors are represented as two sides of the triangle with the order of magnitude and direction, then the third side of the triangle represents the magnitude and direction of the resultant vector. Now let's consider this diagram. The two vectors represented as two sides of the triangle with the order of magnitude and direction are OA and AB, that is vector P and vector Q. The third side of the triangle represents the magnitude and direction of the resultant vector, and that is OB. The resultant vector in this case is the R. Resultant vector is the vector sum of two or more vectors. And in this diagram, we only have two vectors, which is vector P plus vector Q. Parallelogram law of vector. Parallelogram law of vector states that if two vectors acting simultaneously at a point can be represented both in magnitude and direction by the adjacent sides of a parallelogram drawn from a point, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through that point. Now let's consider this parallelogram. In this parallelogram, vector OA and vector OD both start from O, that is vector P and vector Q. Now, line OA is transferred to the end of line OD, which gives line DB. Also, line OD is transferred to the end of line OA, which also gives line AB. And this now forms what? A parallelogram. Now, the diagonal of this parallelogram is OB, which is the resultant of the parallelogram. Now, resultant is a vector sum of two or more vectors, and in this case, the sum of the two vectors is P and Q. Let's consider this formula. This formula is gotten from a rule called cosine rule. And this formula can be used to calculate the resultant of two vectors. Now, the two vectors are P and Q. Cosine rule is applied when you have two sides of a triangle with an angle and one unknown side. The first side in this case is P, the second side is Q, and the third side is R, that is the resultant. And the known angle is angle A in this case. Let's look at the diagram. The first side of the triangle we are considering inside this parallelogram is P. The second side is Q, which is a line that is transferred to OA, and we have AB. Now, the third side is R. So, the unknown angle is angle OAB, that is angle A to be specific. Alright, if two sides are given and an unknown angle is also given, using cosine rule, we can therefore calculate the resultant. The scalar product of two vectors. The scalar product or dot product of two vectors A and B is written A multiplied by B is defined as A multiplied by B is equal to the magnitude of A multiplied by the magnitude of B cos phi, where phi is the angle between the two vectors, that is A and B. Now, if X and Y are two vectors with component I and j, X is equal to AI plus BJ and Y is equal to PI plus QJ. Then X multiplied by Y is equal to the product of these two vectors, which gives us APII plus AQIJ plus BPJI plus BQJJ. And recall that I and J are mutually perpendicular unit vectors. Unit vector means that the magnitude of that vector is 1 and it is perpendicular because it forms a right angle. Hence, I multiplied by I is equal to 1 multiplied by 1 cos 0 degrees, which is equal to 1. I multiplied by J is equal to 1 multiplied by 1 cos 90 degrees, which is equal to 0. J multiplied by I is equal to 1 multiplied by 1 cos 90 degrees, which is equal to 0. J multiplied by J is equal to what? 1 multiplied by 1 cos 0 degrees, which is equal to 1. Therefore, the vector x multiplied by vector y is equal to AP plus BQ. We make use of 0 and 90 degrees because the angle between a right angle triangle is 0 and 90 degrees. Example 1. Find the scalar product of the pair of vectors below. Vector A is equal to 5i plus 2j and vector B is equal to 2i minus 3j. Considering these two vectors, the scalar product of these two vectors, however, is a dot b. Let's consider the solution. A is equal to 5i plus 2j, as I said earlier, and b is equal to 2i minus 3j. A multiplied by b is equal to 5 multiplied by 2 plus 2 multiplied by minus 3, which is 10 minus 6, and that gives us 4. Angle between two vectors. From the definition of the dot product of the vectors a and b, the angle phi between the vectors is defined as cos phi is equal to the product of the two vectors over the product of the magnitude of the two vectors, which is a multiplied by b divided by the magnitude of a multiplied by the magnitude of b. Example 2. Find the cosine of angles between vector a and b given that vector a is equal to 3i minus j and vector b is equal to 5i plus 2j. Solution. Let phi be the angle between vector a and vector b. A is equal to 3i minus j and b is equal to 5i plus 2j. The square of the magnitude of a is equal to 3 square plus minus 1 square is equal to 9 plus 1, which gives us 10. Therefore, the magnitude of a is equal to square root of 10. The square of the magnitude of b is equal to 5 square plus 2 square, which is equal to 25 plus 4, and that gives us 29. The magnitude of b is therefore the square root of 29. The product of the two vectors is equal to 3 multiplied by 5 plus minus 1 multiplied by 2, and that gives us 15 minus 2, and that is 13. The cosine of angle between two vectors is derived from the dot product of vectors, and that gives us the product of the two vectors divided by the product of the magnitude of the two vectors when the angle is less than 90 degrees. Cos theta is equal to the product of these two vectors, which is 13, and the magnitude of one of the vectors, which is square root of 10, and also square root of 29, which now gives us square root of 10 multiplied by 29. Therefore, the cosine of angle between the vectors is equal to 13 divided by square root of 290. Now, by rationalizing this result, you multiply the numerator and the denominator by square root of 290, and that result gives us 13 over 290 multiplied by the square root of 290. All right, thank you for listening.